Okay, let's do some examples where we use congruent complements and congruent supplements to show just a few things. I've got all these different angles up here, all these different things going on, and I'll use these down here. They don't even really need to be lettered, but I'm just showing you that I have all these different angles, and we'll use these with these statements. So we're given the first one. Angle 4 is supplementary to angle 5. Angle 4 is supplementary to angle 11. Well, remember, if I'm saying 4 is supplementary to 5 and 11, that feels like transitive. It's not transitive, it feels like it. We can say that angle 5 is congruent to angle 11 by our friend, the congruent supplements theorem, right? The congruent supplements theorem states if I've got one angle that's supplementary to two other angles, well, then those two angles it was supplementary to are congruent. Easy breezy, beautiful. Let's look at number 2. Angle 10 is complementary to angle 11, and angle 5 is complementary to angle 10. Well, again, I have 10 complementary to two different angles, 5 and 11. So then, 5, wow, the same angles, right? Angle 5 must be congruent to angle 11 by the congruent complements theorem. The congruent complements theorem this time. Again, because angle 5 was complementary to both, angle 10 was complementary to both angle 5 and angle 11. So 5 and 11 must be congruent. Okay, I'll write this. 6 is complementary to 1. Angle 6 is complementary to angle 1. Angle 11 is complementary to angle 3. And there's 2 steps for this one. Well, the first thing I'm thinking is that 1 and 3, those are congruent by the vertical angles theorem. So that's really nice that I already know that these are congruent. So let's say that, right? I know that angle 1 is congruent to angle 3. The reason being the vertical angles theorem. And then, so my conclusion from that, since those two are congruent, 6 is complementary to 1, 11 is complementary to 3, which is kind of like 1. So we could say 1 is complementary to both 6 and 11. So angle 6 is congruent to angle 11 by the congruent complements theorem. Nice. Okay, we've got a few more. And really, you don't even really need the pictures for this one, which is kind of nice, for some of these at least. If AB is perpendicular to CD, how could I say that angle 8 is a right angle? AB perpendicular to CD? Well, that is quite simply, that's just the definition of perpendicular lines, right? Definition of perpendicular line states that if two lines are perpendicular if they meet at a right angle. Simple as that. So if they're perpendicular, then 8 has to be a right angle. Okay, what about this one? If AB is perpendicular to CD, then 8 is congruent to 9, right? If these two are perpendicular, then 8 is congruent to 9. Well, remember that part of our definition of perpendicular lines is that if two lines are perpendicular, they have congruent adjacent angles. So I would say this, two lines, we don't really have a good way of saying this. If two lines are perpendicular, they have congruent adjacent angles. That was one of the pink sheet reasons that we talked about. Because, right, 8 is 90, 9 is 90, they equal each other, they're congruent. Okay, let's look at a different set. If J is perpendicular to 9, then 11 and 12 are complementary. So these two, we're saying if these two are perpendicular, these two are complementary. This is someone that I feel like people forget about a lot, this poor guy. This is the perpendicular pair theorem. And the perpendicular pair theorem just states if two lines are perpendicular, then the angles inside those lines are complementary. The two angles inside those lines are complementary. Not too bad. Perpendicular pair theorem. I don't know why I used lowercase for that one, but that's fine. Okay, the last statement. Can you believe it? If line segment AB is perpendicular to line segment CD, angle 8 is a 90-degree angle. Okay, this one's tricky because we actually need two steps. First, we need to say that angle 8 is a right angle. And we'd say that, we already said that up here, right? That's the definition of perpendicular lines. And you could write perpendicular instead of perp if you want. That's fine. Definition of perpendicular lines. Then I can say angle 8 is a 90-degree angle. Well, if something's a right angle, we know it's 90 degrees by the definition of right angles, right? Or the definition of a right angle is that if an angle is a right angle, it's 90 degrees. And there you have it. That is all of these reasons that we kind of pulled out and pulled together using all of our different complement, supplement reasons. Yeah, we proved a lot of things. We justified a lot of statements using those different reasons. So hopefully that helps you see how these work in action.